Oh no. Okay, so it's 11:40, so let's start. So I want to bring you on a journey from monolithic-based applications to something distributed, to microservices-based application. And my name is Michal. I'm a lead developer at a company called JustGiving. I was born in Poland, then I moved to London 2.5 years ago, and you can find my Twitter handle. It's here, and you can check my blog too, if you want to. So you can ask this question like microservices again. Aren't we bored about this topic? Yes, this presentation will be about microservices, but in a bit different way. Because microservices are right now on a race, and a lot more people right now are looking for them, and you can see this Google Trends chart that people are really looking for it, and people are just Googling for it. So people are looking for them, but we as developers, we kind of mostly, I think, concentrate on the positive sides of going with distributed systems, going with microservices and things like that. And this talk will be mostly about anti-patterns and what we have found and what kind of mistakes we have did in the process from going from monolithic non-distributed system to distributed one. So this is my team. And you can see from the happy faces that my company is probably awesome. We haven't forced them to really smile. And those are the people responsible for our product. And we are a tech for good company based in London. We are a social giving platform. We have millions of users. We have helped to raise more than $4 billion so far. And we have helped fund thousands of causes around the world. So we are helping people to raise money for things like disasters, like there was disaster someone and people would like to help, or someone is really sick and he needs help, so people are raising money for him. So we are a platform like that. We are helping people to do that. And the reason I mentioned that, because we have kind of like a big numbers, and there are a lot of people using our platform, so the move from non-distributed system to the distributed one won't be that easy with such a big scale. And all of this was powered by this, like monolith and one single database. And in numbers, we had one Visual Studio solution with 120 plus projects. There were multiple products in there. We had one big database, which has a lot of data. Our deploy time took us 60 minutes or more, and our release time was like 2-3 week releases. The platform was so big that we had to spend 1 week to basically make the system stable and find it and make sure that it works still fine. And then we decided to do transformation. And we decided to do transformation because we kind of felt that we are reaching the limits of our monolith. After 8 years of having this monolith in there, we kind of felt that, okay, maybe it's a good time to do something else, try something new. Hoping that maybe by going to distributed world with microservices approach, we will gain more agility. So this move was a bit also based on hype, but still, in the end, it was really a good idea, and it paid off for us in our environment, in our product. So we did it in a way that we took the monolith and slowly, piece by piece, tried to cut it down to smaller pieces and move them to microservices. So you can see like monolith is getting smaller, but microservices estate is getting bigger and bigger. In the end, we still do have some parts of monolith which are kind of like critical that we haven't yet moved, but we are slowly getting there. And we have a lot of microservices in there. And this process took us 2 years, and it's still going. So it's not like finished. It's not yet finished. And right now, it looks like this. So we have microservices, a lot of them. Consumers, like web applications, mobile application, APIs that are consuming the microservices. Databases, providing the data, and all the different layers supporting this architecture and everything there is, like layers like cloud, messaging, monitoring, logging, and things like that. In numbers, we have hundreds of microservices right now. Our deploy time was cut significantly to 5 to 10 minutes, but that's kind of obvious because microservice is supposed to be small, so deployment time of microservice should be smaller. And we kind of embraced polyglot persistence, trying to use different types of databases. It kind of failed in a way, but I'm going to talk about it later. And also, instead of having 2 to 3 week releases, we try to have right now daily releases. And so far to this day, we probably have did like 400 plus releases so far. So instead of doing a 2-3 week release, right now we can do release daily. And this also have kind of like freed our developers, make them free, because right now I'm not afraid to push stuff to production because I can just release stuff as soon as possible. And even if something breaks and is affecting users, I can just push hotfix very, very quickly. So maybe you heard about this term when you were looking into the microservices world. There is a concept called monolith first, and if you go to Martin Fowler's blog, he is mentioning pretty nicely why probably monolith first is a good idea. And our product, our company, was a perfect example of monolith first. So we have our monolith, 8 years of gaining just finding our problem space, finding our what we want to achieve, and then we took this monolith first thing and moved it to microservices. So what we can share today, what can I share today with you? Of course, like I mentioned, anti-patterns. And I will only mention the most important ones. I could do this talk for 4 to 5 hours, but sadly I had to fit everything into 1 hour. So I will only talk about MicroMonolith, synchronous integration problem, 1DB to rule them all, and top, the best one, the underestimating the cost of this move. So let's start with MicroMonolith. So like I mentioned before, we had this monolith and this database, and we decided to move it on. And ideally, I would love to look at our monolith in that way, like a perfect hexagonal architecture with our application domain inside, all the different adapters, making sure all the different adapters providing functionalities and internal, external integrations, right? But in reality, we know how it looks like, and it mostly leads to something we call big pile of mud. Now, I don't like this name because even if this is kind of nasty and it looks bad, it's still kind of functional, right? Because it still provides business to value, it still works, and it still pays our paychecks and everything. So we can't make it, so it's really not that bad. It has to be functional. It's also a bit beautiful because you have to be an artist really to work with a system like that. And just not to be too positive, I'm going to add mess so that you guys won't go through this talk and tell everyone that Michael is telling everyone that big ball of mud is really functional and beautiful. So let's just add mess in there. And how it happens that this big ball of mud is there in the first place, and I even think that most of the products will go in that way. It's because the IT industry is complex. Projects are complicated. And we do development and exploration in the same time. So we don't have a perfect blueprint or perfect, specification of our system that will fit into the market, which will help the customers and will be perfect from the beginning. While developing product, we still are exploring our domain, our problem space, and what we want to do. So this might lead to suboptimal decisions and suboptimal choices. And of course, there are also changes. The market can change, the product can change, the specification can change, people can change, everything can basically change. And there's also market pressure, like pressure from the market, which is something I was not liking when I was younger, because as a younger developer, as a junior developer, I was looking as a tech, as a sacred. Tech is always right and tech is always good. But then with more experience, I have found out that tech and our products are built to provide value, so business is also important. And I believe in something when business and tech, they are fighting together. If there is a perfect balance of business and tech having the same political power, we will build something called good enough software that will fix our tech needs and our business needs too. But sadly, sometimes it happens that technical side has less political power and business side has more political power, and this leads to business basically handing developers and tells them what to do, right? And this leads to sometimes not perfect solutions, not perfect projects. On the other hand, if technical side has too many power and business side doesn't have much more power, the developers will create over-architecture madness. Because I've seen it everywhere. If developers have too many political power and too many influence, they will create over-architectured software. Little break. So our first iteration, when we moved the monolith into microservices distributed world, look like this. And you can see that it kind of hasn't changed. It looks very similar. And instead of having big ball of mud, right now we have distributed ball of mud. So we had already a problems and not perfect solution in the first place, but now we also added another problem, which is distributed our problems. And that's how I call it like MicroMonolith, because it mixes the two worlds together. And MicroMonolith was like a natural step, Because as developers, when we develop this product for 8 years, this our monolith for 8 years, we have kind of acquired the prior knowledge and habits on how to do products. So I wasn't really surprised that we have gone that route, that we have kind of recreated the same thing we created at the beginning and just slowly explored the distributed world. So I wasn't expecting like a perfect product from the beginning. And just like with Conway law, when structure of a team doesn't change, the code will always stay the same. So the code is driven by the organizational structure. So if you want to create a distributed system, you not only have to embrace the technical side, you have to look into the organizational side of the things. So distributed systems, they require distributed teams too. And changes are difficult. Changes in organization, in culture, in how we work, in our habits, in our experience. This is difficult because the way the brains work, they just create those connections inside. And if you do this, if you create this connection, it's really difficult to just reroute the brain, like rewrite the brain. So the only way to do this is to experiment and try new things and even fail. And MicroMonolith was like a learning process for us. So we did it, we have kind of failed, and we took the lesson. We found out what's wrong in there, and we just applied a new experience, new knowledge to create maybe something better. And it's really important to fail fast but learn, because failing is pretty simple, you just fail, but learning out of it is much more difficult. The other pattern that we have found, which is tied into MicroMonolith and our previous experience, is synchronous integration. So as a web developers, we kind of, working in non-distributed world, we kind of look at the system from a non-distributed world. So we kind of have created software that was working in one process. So we haven't really worried about non-distributed system. We didn't have any knowledge about it. So as a web developers, because we like HTTP and REST, we kind of integrated all of our microservices in that simple way. They were just calling each other and being dependent on each other. And because we've been using HTTP, it created synchronous integration problem. And this is kind of problematic because if one microservice goes down, all the dependent microservices will also go down. And it's not only tied into the microservice, but also the HTTP protocol, the transport protocol, connection, everything can be problematic. And because we had no experience with distributed systems, we kind of underestimated the network layer, which is a nasty beast because it adds problems like latency, complexity, debugging problems, because it's not that easy to debug distributed system like non-distributed system when you can just step into the debugger, step into the process. With distributed system, you have to have token that is shared between messages, and then based on this token, you can find out what's happened with this message going through and passing through different microservices. And there is also security problem, and of course, connectivity issue that I showed you before. So we kind of like thought that we kind of like forget about the network, and you can't beat the network, you have to embrace it. And network can be really nasty, and you have to assume that there will be problems, and you have to prepare your system to be able to cope and fight with those problems. So one way to do this is to introduce asynchronous integration between your services. In that way, when one service goes down, the other services can kind of function on its own, not being affected. And then you create something called occasionally connected apps, so occasionally connected microservices, so that they don't have to be connected all the time. They can go offline, they can lose connection to itself, but they can still work fine. So if HTTP is synchronous, how can you make HTTP asynchronous? Well, you have to add a middleman between the protocol, between the two calls. And one of the middlemen that you can use is message bus. So instead of tying the microservices to each other, you can just tie microservices to message bus, and then microservice can push messages to the bus, and it doesn't care. It's not worried about who is listening there. And it's very simple for push. If I change some state, if I want to notify someone, I just push a message, and that's fine. But what about pull? Like, what about scenario when blue service is dependent on the green service data? What happens if green service goes down? Where will the blue service get the data from? So that's where you have to go into distributed data too, which means like in this case, when you have services and red service dependent on the other two, if one of them goes down, the red one cannot operate because it needs the data from the gray database. So what you can do, well, you have to distribute the data. You have to introduce another database in your red service and kind of keep at the normalized state of your other services in this microservice. So when the other service goes down, this database can still function because it's kind of like synchronizing the data with the other two. It's keeping the same state, or not the same state. It doesn't have to keep the same copy, but it can kind of normalize the data it needs and just keep the data it wants, right? So that's how you can create a connection and still maintain connection if services require the other service to function. The other problem with synchronous communication that we have found is also related to mobile apps and web apps. So the old approach that we have used in our apps was based on having a monolithic app. And if something went down, the whole application went down. So going to distributed world, we kind of also embraced distributed apps. So instead of having one big monolithic app, we kind of split the app into different sections. And then if section that is dependent on some microservices goes down, like this microservice goes down, we can hide this section from the user. So the user doesn't have to be even aware that there was a problem. Like an example, my product has some commenting system inside. If a commenting microservice goes down, I can just hide the comment box. I can just hide it from the user. A user won't be even aware that there was a problem. You can also apply it in a different way, and you can completely disable the feature. Like you can still show the comment box with old data, with the data that you cached and are keeping some stale data somewhere, but still you will disable like interactions. From the user point of view, like user can't update, user can't delete comments, but at least he can see the state, the old comments. And this distributed app thing also provides better scalability because you can scale different parts differently. Like if you have some critical part, you can add more instances in like AWS or Azure. Or you will even increase your reliability because if some of the microservices goes down, you can also still have microservices supporting the other part fine. So bringing it together, like those synchronous problems, this is a brief history of one app that we have made. So we have started with mobile-first web app, and it was based on Angular. Later on, we moved to React, and because it was client-side JavaScript, we had to have some public API. And this public API was just a gateway to microservices. And those microservices were keeping state in one big database. So this is our first step of what we did with one of the products. And you can see here, there will be a problem, because if the database goes down, the whole product goes down. So we had to distribute the data and move the data closer to the microservices. So right now, microservices, they do own the data. So if one of them goes down, at least two microservices can still support some parts of the product. You can even go further away with that and add a caching layer into your public API. So with this approach, if this goes down, you're still keeping some state, you're still keeping some data in there. And in my case, in my product, we do display a static page which doesn't have any interactions. So user, if he goes to the page, he will at least see something. He won't be able to interact with the page, like add comments or do something about it, but still, he will be able to have a static page visible. We even went further, and in our critical system, the most important part of the business is donations. So making sure that people can donate money to the causes they want to support. So even if our whole architecture goes down, we moved our donation system to a separate system completely that was maintained by a different team, and that team supported a higher reliability, higher scalability. So even if everything went down on our product, we could still redirect the user to make interaction in external product. Then we also had to add some external dependency. And just to make things simple at the beginning, we have kind of integrated those dependencies to existing microservices. But this created a problem, like those microservices right now are doing too many things at once. So we had to introduce another layer of microservices, just trying to be like a liaison or a gateway to those different external systems. And later on, other teams have joined in and kind of used our microservices. So we have right now shared microservices around the teams. But to make the system even more reliable, you can see here clearly that this will be a synchronous integration. We also added message bus in between them. So now if this part of the systems goes down, our microservices supporting my product, they can still push some stuff, some messages, some notification into the message bus, so that when the system is back, the system can just like reply in the messages or just take the messages and do its own thing. And later on, we also had another integration to analytics system. And in here, we added event stream using event store. Now, event store adoption in our company was kind of funny because we kind of understood the event sourcing concept. We knew that you can't treat event stream like a normal message bus or something like that. This is basically a database. But still, developers and I also did the same mistake. We kind of used this event stream and treated it as a message bus. Don't do this. And if Greg Young is listening, yeah, Greg, we did it. So be pragmatic. So you have to approach your application really from simple. Start from the simplest possible solution. And you have to find out which part of your system are really scalable, needs the most scalability, and needs the most reliability. The other thing we have also noticed that is related to the monolith and our old ways of doing things is approach of one DB to rule them all. So in our old monolithic system, we had the database, which was monolithic database. And monolithic database has some special characteristics, like it has business logic. So after 8 years of having a monolith, we have kind of built a business logic inside. And I think it is natural. We try to forget about it, we try to avoid it, but still it happens because business needs reports, business needs some logic implemented. You're starting as a developer, then you add business intelligence team or team like that, and they will do stuff on your database. They will create complex business transactions and things like that. So our first approach to still maintain it and still be able to cope with those requirements, existing requirements, we have kind of created a system like that. So all the microservices, they were dependent on one data. And this is kind of problematic because it was a natural step. It felt right at the beginning, but then it was a single point of failure. If a database went down, we had a problem. It also creates a problem with data storage tie-up bias, because if you are tied into one database, you will think about your problems from, we had a SQL relational database. So all the problems for us look like relational and SQL based. And of course, your services are also tightly coupled. And the most important problem is that you have non-distributed data model, which is kind of problematic because as developers, we do sometimes, or even most of the time, follow this anti-pattern called that data model is affecting our code. Yeah, this is anti-pattern. We shouldn't be doing that, but still, it feels like most of the teams, they just go into that route. And if you want your teams to have distributed code, you have to distribute your data. So in order to enhance and influence your team, you have to distribute your data, because otherwise they might, again, fall in the same problem. So if one database is problematic and it's complex and it's not perfect, maybe we should do a database per service. Well, it looks good on paper, but it also creates a different set of problems, like data aggregation. Having one database with different tables, data aggregation is very simple. You just do a join in a database, and that's fine. Doing a join across different databases spread around, and maybe even having different systems like NoSQL systems, things like that, it's getting really, really complicated. Supporting business transactions, distributed transactions, is a complicated thing, and this is one of the biggest problems of IT. And also increased maintenance. This is kind of very problematic because keeping one database afloat and stable is much more simpler than having multiple tens of databases and making sure they are fine and they do work and they are stable and they are operational. So we also started simple. Instead of going for a full-blown database per service distributed data, we kind of started with simple. We kind of did baby steps. So we still have one database, but instead of tying into our own existing data model, we created table per service. So this is like a first step to distribute the data. You can even go further. If you need to support more complicated data model, you can add schema per service, which is also very useful. But you have to be careful, because monolithic database, after 8 years, it creates certain habits that are very painful, and it's really difficult to change people and their behaviors, especially different teams, not maybe even tied to developer teams. I had a problem. We had a problem once that my team had owned the table, and we had the service that was basically owning this table. And we had CRM team that is doing marketing actions, and they need the data. They needed the data from our product to send some emails to our customers. So in the old world, when they had one database, they just checked the database and, there's a table, I will just use it, right? So they kind of tied into this table like that. And now the problem is they are coupled with this database without even telling us. And they kind of are coupled by using the database system, which is problematic because if I want to change the data right now, or the data model or I want to move the table to maybe a different database, or I want to move the table to database per service approach, it will break their thing. And we had this problem. We have changed our database. They basically, all the marketing actions haven't went out, and they were kind of not happy about it. The best approach is they should ask you about how can I access your data, and then you can expose this data through some API. So instead of tying yourself into the table and the database, you are exposing the API. But it's really difficult to change people's behavior and like influence them. So they will ask you questions like, because they used this old approach, they were so used to using the one database, the data is there, I can just use it. But they kind of didn't feel that they need to do this. They don't need to ask the team about how to access the data. So after this, after you slowly started with table per service or schema per service, you can slowly start introducing things like database per service, or even a bit of compromise like having a database per product, which is like a compromise. You still have one database that will affect your product, but at least you have more control out of it, and maybe you can move some business transactions or some data aggregation, also complex reports out of this big monolithic database. And it's also important that you have to, instead of relying on joins inside tables, you have to start doing application joins. So what application joins, how it looks like, it's basically just one microservice aggregating the data from other services. Yes, and the last pattern we have found is underestimating the cost. So in the old monolith world, we had been renting our servers, and this was based on our prior experience. So we had the 8 years of acquired experience on how to work with rented servers, and we had it under control. So the cost over time chart looked kind of simple. It was linear, and we could really we always knew where we are heading and what will be the cost, how much we will have to pay for it. So, and after embracing the distributed new world that we weren't really aware of and kind of we had no experience with, and we went to cloud, to AWS, we kind of had a spike of our cost increasing, and then people got worried, like, what the hell is happening? How are we going to handle it? How are we going to support it later on? It's not scalable because with more users and with more users going into the platform, the cost will increase and increase and increase. So this was the time when we had to introduce spending control. And spending control in the old world was fine because we had operations team that, based on their knowledge and their experience, they had been doing this by themselves. But going distributed and exposing the cloud to developers, we kind of showed the developers AWS, and they started doing awesome things there, like creating instances out of nowhere. So we were burning money, and now we had to move the spending control out of operational team and move it also and spread it out to the whole team. So we introduced things like planned downtime, which is like having 3 different environments at production, staging, dev. We still keep production safe and fine operational for a whole day, but if developers are sleeping, we don't need dev and staging. And it's simple, it won't create a lot of savings, but still it sends a clear signal to the team and people around the team that we are treating this seriously right now, and we are doing things about it. We want to care about spending and cost control. Right now we're also looking into Docker, which is a nice concept, but we are just starting up, and instead of having one instance holding the microservices like we do right now, so every microservice has 4 to 3 instances right now, we want to go and have one instance with container that could hold different microservices. Now, it won't be probably suitable for production because still in production we want to have ability to scale everything fast and nicely, but for dev and staging, I think it will be perfect. But the biggest thing that we are introducing right now, and we have introduced so far, is that we had to introduce cost monitoring. And because AWS, Amazon, doesn't have any tool to really show you how much things cost, we had to build our own tool. So we just built this tool that shows us the increased costs over the week time, or the whole increase. So this is a chart after we have started monitoring the cost, so you don't see this big spike at the beginning. But you can see that it's kind of like linearly increasing slowly over time. And you can have more reports like check which services are the most expensive and things like that. And also we have a report that shows us what was the increase by weekly basis, and which services are increasing the most and which services we need to look at. And this cost monitoring tool was really important for us because we wanted to make the cost control part of our development culture, part of our deployment pipeline. And it's really important because if you give developers tools, they will start using those tools. Then you have to teach developers how they should use those tools properly. So introducing cost control into development pipeline means that you have meetings and you have some, you are basically checking how much does it cost. You're not only checking what's the performance of your application, you're also checking how each service costs, how much does it cost. You can even create like hackathons and have teams competing with each other, trying to cut the cost most. I know that you can game the system and make a microservice that is very expensive, and then it's very easy to just cut the cost, but yeah, you get the idea. So after introducing those things, we have kind of slowly get back, and our costs have decreased a bit, and then they stabilized. And if you compare it to the old cost chart, it's still bigger, and the increase over time will be bigger because with scale, it will get bigger because you can see that the line is different. But still, with increased op cost, we have kind of decreased development time costs. We have gained more agility, and we have right now faster time to market with the with the distributed world because we can deploy really fast and we have daily releases. So still, in the end, this was very helpful for us. What's the time? Okay, fine. So in a summary, the road from monolithic application to distributed application should be simple, but it's not really that simple. It's complicated. And you will, on this route, you will probably you will be derailed by sometimes, and you will fall into the traps like we have, like to these traps like MicroMonolith, one database, synchronous integration, and different org changes and things like that. And when you do this, it was a learning process. And when you also do this, probably in your companies, because cloud is not going away, we will have to embrace distributed world. When you do this, you will also have to go with some maybe different route. And probably you won't fall in the same problems like we have fallen into, hopefully, thanks to this presentation. But you will probably find different routes and different ways how to do this. So your route will be different, completely different. And it's important to share this knowledge so that we will be able to find a perfect route. So it's like with the book from Gang of Four, the design patterns. They basically gathered the community knowledge in one book and showed everyone how to do patterns and design patterns. So right now, we are slowly embracing the distributed world, and distributed world becomes mainstream just like Docker and containerization have been. So distributed world was already there with service-oriented architecture, but not many companies were doing it because it was complicated. And with microservices, I think it's getting into the mass public, and more developers will do this. So it's really important to share the knowledge and gather all the patterns that are useful and to help everyone to be able to move faster from monolithic to distributed application. Any questions? Yeah.
So you mentioned having a BI type of team.
Yeah.
Integrating the database and using an API instead.
Yeah.
How do you feel about giving them a view in the database that they can directly talk to if they don't want to use an API?
Well, that's a good question. So the question is, if the BI team that we have in our company is so accustomed to the old ways of things and they want to look into the old way and they would like to get access to the database, how can we make them happy so they can access our database, this my specific database, right? So I think there is no easy answer to it, and ideally they should also be, you should convince them that this is the new thing, this is the new world, and you have to trust us. So we will expose the data that you really need, and you have to tie in through ourselves. Because tying yourself into the database will create more problems. So they have to understand it. Right? So it's not only you can't only change the culture across the development team. You have to change the culture of distributed world across the whole organization, or whole team. So I don't know if this answers your question, but there is no easy way to do this. Yeah.
You said that you treated your event stream like a message bus.
Yeah.
Can you expand on that?
So event stream and event sourcing is like a database kind of concept when you have events changing the state by state, right? And you can then replay the events and you can get the snapshot of the database. And this is how you should use it. You should use it as a database with some events that are applying state changes. So we use it as a message bus. and we just basically stored messages like notification message, which haven't been even changing the state. And this is not a good idea, because those kind of messages you would like to replay. And replaying events in an event store, an event sourcing concept is not possible. It is possible, but it's like it doesn't feel good. It doesn't feel right. So using event store for message bars is a really bad idea. Does it answer your question? Yeah. Okay. Yeah. You first.
You mentioned doing application joins.
Yeah.
Did you ever see any performance problems? I mean, with big data sets?
So there is a question about application joins making performance problems. Yeah, there will be performance problems, but with multiple microservices, there is a chance that you will be able to scale your microservices much, and you can distribute the work kind of nicely, right? So if you even have to do like a complex join, you can kind of distribute it. It's much more complicated. It's not that easy like doing it in a database, but it's possible. But yes, there will be an impact on your performance. And some of the reports that we have tried to move, we weren't able to move them. And right now, that's why we have still this little part of Monolith, because we can't move everything into microservices world. There are still reports and some business logic that needs to be maintained because our business needs to be happy about it. So we haven't moved most of the things because there was a performance impact on it.
Regarding using APIs
Yeah.
to access databases, don't those APIs kind of explode for having one method for each query, and you end up with 200 different methods for some different type of joins and so on? And isn't it hard to maintain? And
So the question is, if you're exposing your data and database access through some APIs and through the API, not only using the database, the question is, will the API calls and different API calls expand to like a non-maintainable thing? Because, you know, BI developers and SQL developers and people like that, they do create complex reports, complex logic in there, and sometimes your API won't be suitable to do this, but then you have to add another API call. And yes, there was a problem with that. And sometimes you have to create, you have to work closely with your BI team to really find out what they really need, because sometimes they just ask questions for some new API endpoints, and it leads to, and then they just use it one time, and they just stop using it later on. So yeah, but this will increase the burden. So some of the parts you can't move out of your system. Yeah. Yeah.
I'm just wondering, how did you deal with the challenge of transactions? Because we are looking into moving from the big monolith into microservices, and the one thing that we can't get our head around is how do we deal with the transactions in this new environment?
So how to deal with transactions in distributed microservices world? So I'm not an expert. I don't know the perfect answer to it. But I think that instead of working with transactions and looking at it from the old way of looking at things, you have to embrace event-driven architecture, and maybe even eventual consistent event-driven architecture. And that's, I think, you completely change the paradigm of how you treat the data. So instead of looking at the problem from the old perspective, you have to change completely the way how you look into transactions. So making distributed transactions is complicated, and probably there are books and better experts on it. I won't be able to tell you how to do this. I would try to change the paradigm and completely try to move out of it and embrace eventual consistent event-driven architecture or something similar. Does it answer your question a bit? Okay. Any questions? Yeah, sure.
So when you move to microservices, were you able to, do you have some service that is absolutely critical? You have to be absolutely sure that that doesn't go down. And in that case, if you can find some of this occasion, would you use something, a different kind of technology that ensures that, like Erlang, for instance, these things can go down? So
the question is, if there's a critical path in your system that has to be always online and it's really important, would you use different technology like Erlang? So I don't have any experience with Erlang. I heard good things about it, but I had no experience with it. But yeah, sure. Like we have our financial system is not distributed. It's still being like a monolithic system outside, because we have to be PCI compliant. So this system has to be too close to outside. And you need a certificate if you want to access the system. So yeah, there are parts of the system that we still haven't moved on, and we will probably not move on because we can't just distribute like our PCI compliance system that was already certified long time ago, and it won't be possible. But yeah, looking in different technologies will be a good idea. But I think it will be. You have to do this. You have to look at different problems using different tools. So you can't just. The microservices are not silver bullet, and distributed systems are not silver bullet. You have to look for different tools. You have different kind of problems. I don't know if that's answering questions a bit. Yeah. Okay. Any questions? More? Yeah. Sure.
What type of event store do you use?
What type of event store do we use? So I know that there is one that you can use using a SQL database and install the events in the database. But we use event store from Greg Young, which is like a application that you just install and you just store it somewhere. And we just use event store from Greg Young company. Yeah. Any other questions? Yeah. Sure.
Did you face any challenges from the business when you decided to move to microservices?
So that is an excellent question. Like, how will business like the move? Yes, this will be costly move, and this is a significant investment. And of course, business won't like it. But we had support from our excellent CIO and CEO, and they were aware of the microservices and distributed world. They were aware of that we have to move there slowly because the cloud is not going away. So we will have to go there one day. So with their support, they were able to communicate with the business and explain to them and always fight for us and always explain them why this is important. So if you want to do this thing in your company, you have to get support from someone that will support the idea. It won't be possible to just do it by yourself as one single developer or even as a team. You need people higher up supporting the idea. So without the CIO and CEO and CTO help, we won't be able to do this. Yeah. Does that answer your question a bit? Yeah, because convincing business to it will be difficult, like with everything. Like, business, they need value. They need to increase the value. They need to make the platform that provides the value. They don't want to get into like, what's this distributed thing? We don't care. We want you to develop stuff that makes more value. So this is when I mentioned this technical side and business side fighting together for resources and time, because our technical side has a support from political people that do have a lot of political power. We could fight for this idea and this move. And in the end, later on, after some time, we have prepared some reports and presentations to the business that showed them that with microservices and distributed approach, we have better time to market. And you will be surprised, but they kind of haven't, at the beginning, they haven't got the idea that this will be a huge thing, but now they really appreciate it, that when they have a request and they want to change the product, we can just deploy something in hours instead of waiting 2 to 3 weeks for a change, right? So at the beginning it was difficult, but after some time when they've seen the benefits, it really got to them, and they are in business is really happy about it, and right now they are supporting it fully. More questions? Okay, there are not more questions. So thank you for joining my presentation. Yeah, don't forget to vote.
Thanks.
Yeah, awesome.